Hello and welcome back to another episode with Sharp Education. I'm super excited for this episode. This is going to be the last more technical side of logistic regression analysis before we just get to making trading strategies with it. And I think at the end of this episode, if you followed along with the creation of our target variable to be binary, the confusion matrix episode, and this episode, we can and the sigmoid activation function. That's a lot of information, and if you're understanding it, we can consider ourselves not, professional experts, but we're really knowledgeable in this space. So this is going to be the last episode that I'm going to be providing on the technical side of logistic regression. So we can really know what is going on when we make a logistic regression output, and we can understand how to optimize it, what to tailor, what to adjust. We're not just going to be creating the output and making a trading strategy with it. We're going to be creating the output and understanding how to make the best trading strategy with it. You're going to be good at this. You're going to be good at it in the same way that we're now good at linear regression. You know those four assumptions necessary for validity. So you know what to adjust. You know what's wrong, what's right, and where to look for opportunities. This is the groundwork for creating competitive trading strategies, not just listening to me, copying it, and then seeing if it's right or wrong, and then when it's wrong, it's your fault. None of that bullshit. Today we're looking at the receiver operating characteristic chart, which is the area under the curve. Now, this is the final plot that we're going to be looking at of our logistic regression model. And it tells us similar information to the confusion matrix, but there's an important difference. The confusion matrix just tells us, based on our cutoff, what have we gotten right, what have we gotten wrong. Like if we set the cutoff to be 0.5, most of the predictions are above or below it. And then when it's predicting up, generally speaking, there's more true positives than false positives, and there are more true negatives than false negatives. But that's helpful. It's much more helpful than just an accuracy rate, but it doesn't tell us whether or not we've optimized that cutoff threshold. And this plot is going to help us do that. Just looking at these plots are super helpful. So what are we making? We're making the receiver operating characteristic chart. How are we going to do that? I think we're going to import it from sklearn, just like we always do for these sorts of plots. You'll notice that the confusion matrix chart we made is much more beautiful than all of the other plots I've shown you. It's because I just imported it from another package. So yes, we are going to be importing this from sklearn metrics, just like this confusion matrix plot right here. So we're going to be getting a similar plot for the receiver operating characteristic, ROC. So sklearn.metrics import confusion matrix ROC curve. And I think I also want AUC. AUC. Is that a thing? Yes. Area under the curve and ROC curve. And I'm not even going to try to explain what's going on with these two terms just yet. I think it'll be a lot more simple when we have the plot in front of us. So before we generate the regression output, I'm going to be defining creates or add ROC plot. But we don't want the Y predictions in terms of these based on our cutoff. So we have the Y pred probability here in our generate regression output, which remember shows this distribution of predictions. So if it's above 0.5, it's a 1, below it's a 0. But before that, we have these raw numbers, which is what we want to use for our area under the curve. This is how we're going to get that more precise information. So we want Y pred prob. And we also want Y true. So let's do Y true is just our target variable values. So we have that here. It's Y. So we're also going to be just taking Y and the Y predicted probability. And what we need to do for this function is instead of just data frame, we need to return data frame Y and Y pred prob. So in our main function, when we generate the regression output, we're going to do data frame Y and Y pred prob are going to equal that. So we can feed this to our add ROC plot. So now when we make this ROC plot, it's going to have information from our logistic regression function. We need to do these in order. Now, what we want is the false positive rate, the true positive rate, and the thresholds. So 3 things are all going to be spit out by our ROC curve function that we've imported from sklearn. So we're going to do FPR, TPR, FPR, TPR, and thresholds are going to equal ROC curve of our Y true and Y scores. So Y and Y scores. Perfect. And then once we have that information, the receiver operating characteristic area under the curve is going to be a response to the area under the curve function that we have already taken from sklearn.metrics. So ROC, area under the curve, equals area under the curve of our false positive rate and true positive rate. So FPR, TPR. And right now I can completely understand if I've completely lost you. This is a lot of terminology that will make more sense when the plot is in front of us. But remember, the false positive rate and true positive rate can connect back to this confusion matrix. Remember, the false positive rate is how often we're predicting down, but it is actually up. So what is the frequency of this occurring in total? And what is the likelihood of this occurring out of all of the total? So we're making a plot that shows a different way of visualizing the calculations performed by our regression output. So now that we're done with getting the information for our plot, we're just going to make the figure, and I'm going to skip to the point where I've made the plot all beautiful. I'm not going to waste your time with making the title and everything, so I'll be back. Okay, welcome back. So I've made the title related to the strategy of our regression analysis. So we've got strategy here. And that is, remember, we're looking at volume and MACD, the same from our last study. I'm going to be doing a complete episode involving all of our technical indicators together on this study and the open, high, low, and close information before we wrap up our logistic regression section. And so you'll be seeing this title again later. Then we're going to create a plot that shows where it is more effective at accurately assessing true and false positives. And I think that's better explained when I just run this whole code. Hope this works. I didn't add it to the main function. Wow. So now we need to do data frame equals add ROC plot to the data frame, and then Y equals, so Y true equals Y, and Y scores equals our Y predicted probability as generated by our regression output. So this should all work. Okay, that is about as bad as a ROC curve can get. That is horrendous. And I'm going to change this size to be in line with the rest. Just gonna keep it regular. Okay, really terrible. So I'm going to put a picture of a good area under the curve right here. So a great area under the curve extends beyond random guessing. But as you remember from our last episode, when we looked at just the confusion matrix, Control minus, we're pretty much just guessing. We have 2 statistically non-significant variables, and the model is not good at classifying between positives and negatives effectively. So it's just guessing every time, and it guesses down when the majority of our responses are down, as they are on the hourly Lululemon plot. Let's go back to SPY and 1 day. Okay, so let's look at this long diagonal line. This means 50-50 chance, completely random. And what we're trying to do is separate ourselves as much as we can from just completely random. And the more separation there is between our ROC curve and this random dashed line down the middle, the better our model is. Right now, regardless of what our cutoff is, which are these axes here, our effectiveness as classifying between trues and falses are not really substantially different from our baseline random guessing. So with an area under the curve of 0.52, that means that if we're presented with a true or a false, there is a 52% chance of that being an accurate true or an accurate false, which is just not good. It's effectively guessing. It's like you're 2% better than flipping a coin, which is not enough in the stock market. You need to be doing way better. So the optimal threshold is where this orange line is furthest away from the blue line here. But generally speaking, you want to see a nice big extension all the way out. So let's see if we can make a little bit of a bigger curve if we add more information to our study. So let's do volume, run everything, and see if this more information helps us. Well, our area under the curve is now 0.53. Not super exciting, but we already knew this was the case based on our confusion matrix. What we would do is we would set our cutoff to be where this is closest to the top left, where this peak is closest to the top left. And you can see that generally that's in line with 0.54. So to make our confusion matrix a little better, instead of having our cutoff be 0.5, what happens when we change it to 0.54? Does it get any better? Yeah. So our confusion matrix looks a little bit more clearly distributed. So this model has become a little bit more useful. But you can see that it's almost always predicting down, which is wrong. And it's also giving us more false negatives than true negatives or true positives. So when we've set the cutoff to be above the mean just a little bit, 0.54, then suddenly the majority of our predictions are down, and even though there's a better spread, it's not quite as an effective model. So we can adjust the cutoff really specifically. Let's do 0.53 to see if that makes it any better. And it might make our model slightly better, but the problem is we're working with bad information. These open, high, low, close, and MACD histogram technical indicators aren't super helpful. The most helpful ones are actually the low and close prices, which, as you know, don't impact future price movements. But this is a really, really weak area under the curve. And our mission is going to be creating one that extends well beyond this, this average line, this blue average line, in the near future. So that's it. We have two plots relating to our... So that's it. We've got three plots now relating to the outputs from our logistic regression model. We have the distribution of our predictions, which ranges between what we would want to be 0 and 1, but ends up centering around a really small number because of our weak variables. We have an area under the curve chart, which again doesn't show us any meaningful information because we're working with meaningless indicators at the moment. And now we have a confusion matrix as well. So we have three useful graphs, but a useless model. And what we're going to be working on going forward is making this model useful. Now, with our linear regression, we actually ran into the same results, but it was just hard to tell. We came across charts that showed no relationship between any indicators we found and future price movements. And you might be getting bored at this point of seeing me give you information about models that don't work. But the truth is, that's what most of this work is. It's finding information and understanding what works and what doesn't. And in the stock market, when it comes to identifying patterns, 99.99% of everything you're going to do is not finding a pattern. The whole work is identifying a pattern and then capitalizing on that. This is the entire job. It's not glamorous. And a YouTube video like the one you're watching right now is probably not going to be what just shows you the key to all riches. Like, oh, look, here is a pattern. It's not going to be easy. And what I'm trying to give you is the groundwork for coming up with a strategy that helps you identify that yourself. So you don't have to trust anybody in telling you like, oh, this is the only thing that works. You need to buy my course. You need to pay for this. No, this is all free information. And it's pretty solid fundamental understanding of where you can go to build a trading strategy on top of, at this point, advanced statistics. So right now, it's sort of seemed like I'm ranting or talking in circles like, oh, I know that this doesn't mean a lot, but it will if we do something useful, or I know that this doesn't look very helpful, but it could be if it was a good model. And I don't want to sound redundant. So I want to make it super clear that we're not wasting our time when we come across these relationships that mean nothing. This is still good information. It just reassures us that if we're trading using these pieces of information in the first place, we're wasting our time. So even though it's not exciting, like the answer, like, oh, yes, we can finally make some money, it is equally important to know that you are not doing something stupid. That'll be it. That'll be it for today's episode. In the next episode, I'm going to be using all of our technical indicators in the logistic regression function with a new file to see if we can get any inkling of a helpful model with all of our technical indicators. There's 4. And then, yeah, we got big things going on after that too. I have plans. I have plans for this to get really advanced, really exciting, trading strategy, quantitative finance-esque very soon. But for now, it's just statistics. And it is not exciting. So that's it. Thanks for sticking around. And until next time, stay sharp.